Hi, welcome to Marine Physics. Now we're going to talk about electric fields. Every charged object generates this electric field. What is it like? Okay, every charged object is going to generate or set up this electric field. And what matters is what type of charge it is. So first off, if it's a positive or negative charge, it's going to generate a specific type of electric field. And we'll talk about that in just a little bit. But when we put another charged particle, say it is a charged, positively charged object, and we put a positively charged particle near that, it's going to generate a specific force because it's a positive and positive. Remember, we said those were repulsive forces. And then if we put a negative charge near that same positive charged beginning, it would have a negative force. And so when we start to look at this electric field, something is generating that force, and that electric field is propagated and generates that force, whether it be attractive or repulsive. So there's a relationship of the strength of this electric field, and it is based upon the force that's being applied and the amount of the charge of the object that's been placed in that field. And so when we look at that, this is the equation we're getting. This is a relationship. So we take the force that's applied and we divide by that charge, and that should tell us what that electric field strength that's being generated by that specific particle that was there in the beginning. Now, when we're looking at that, that's how we solve for that relationship. But now let's start talking about what happens if it is a positive charge and what happens if it's a negative charge to begin with. What type of field is generated? So when we're looking at the positive charge, that positive charge is going to generate field lines away from it. And so we're going to see these that we represent it with field lines going away. And a negative charge is going to represent field lines going towards. And that's the way they'll set up for each one of the specific charged objects. Positive goes away and negative goes towards. So the electric field is affected by the charge of that original particle that we're talking about that's generating the electric field. The charge of it and the distance between whatever particle we put in, however far away it is, as well as Coulomb's constant. If you remember back to Coulomb's equation, F equals K Q1 Q2 divided by R squared. If we take that and we also apply the E equals F over Q that we just talked about, we can derive this equation here, which is what I just referred to as the things that relate to the electric field strength. So without knowing the force, we could determine what the electric field strength is by knowing the charge of the particle generating the field, as well as how far away the point charge that we put in there is from that original charge generating the field. Now, this is that equation right here that was what we'll use to solve for those. The further away that charged particle is, or that point charge is from the original charged particle, the weaker the electric field will be. And the closer it is, the greater the electric field will be. That's an inverse relationship. So let's talk a little bit about how we would display or demonstrate these field lines. Whenever we're looking at a specific charge, the first thing we have to identify, is it positive or negative? If it's positive, then those field lines are going to go away from the charge. If it's negative, then those field lines are going to go towards the charge. Now, there are some rules that we need to think about. Some of the things that we want to make sure is that those lines are never crossing. The amount of lines that you're given are going to determine the strength of the field, and they're proportional to that strength. So the bigger in magnitude of strength, the more in lines that you should get. And the last thing is that what we mean by going away and towards, if it is a positive charge, we are considering that it's going to leave that particle and go to infinity. That's what we're thinking in our mind. So it's going to infinity. So we draw an arrow. We have to have an arrow. You can't just draw a line. That's what the arrow means. That arrow tip is saying it's going to continue on indefinitely. And the next thing we have to look at is if it's a negative charge, it's going to start from infinity and go towards the charge. That's what we're talking about representing the lines. So here's a couple of examples. If we look at this charge here, this is a negative charge and it has lines going towards it. Now take a look at this charge. This is a positive charge. It has lines going away from it. And that's kind of what we're talking about. Here's an example that you would see with multiple different charges in one setting. I hope those make sense to you. If you have any questions, please don't hesitate to reach out.